Hello engineers. In this video, we will learn about creating the parts family in CATIA V5 environment. Part family is number of parts we have which have a similar shape but different sizes. Like in a particular assembly or in a particular machine, we use different sizes of nuts and bolts. So in our CAD tools, these CAD tools provide us the facility of creating the family of those parts, which will give me the advantage of creating one single part and maintaining all the parameters, or I will say maintaining all the parts in a single file only, having the same shape but different sizes. For an example, let's say I have to create the nut of M6, and in the same assembly I am using the nuts of M8, M10 and M12 as well. So in that case I don't need to create four different dot cat part file for those M6, M10, M12 and so on. What I can do is I can create one, and in that only, using these advanced features, I can maintain all four files. Whenever which particular file is required, I can select that and I can use that. It will be a kind of user created library as well. In any CAD tool you use, there are libraries available. In the library there are some standard parts available. So likewise you can also create the your own library of any specific part, which will be the family of that part. So for that I will take an example of a hexagonal bolt. So this is the hexagonal bolt we have, and I am following the structural bolt, isometric bolt, in which these are the dimensions given to us. And as you can see, there is diameter available, there is length of nut is there, then k value, s value, e value. These values are actually dependent on our diameter. This is what the standard parts maintain. What exactly they do, they maintain the relation between their parameters. One particular parameter will be dependent on some other parameter, and which actually makes them standard, because it is universally understood and universally used in the same manner. So that's why we have this as an example. So first what we will do, we will create this hexagon bolt. After creation of this hexagon bolt, we will be defining the parameters, then we will assign these parameters to the parts, then we will define different values of those parts, and finally we will call those parts into the assembly environment whenever the requirement is. So this is what we have as a hexagon bolt. We will be creating these parameters, and then next we will have these parameters available. So let's say I have to create these five variants of this hexagon bolt, a b c d and e, and these are the parameters given to me, that for a instance the diameter is 10 mm, length is 30 mm. Likewise for b c d and e are given. So by using these features, this part of family thing, I don't need to create five different files. I will create one .cat part file, and I will maintain the complete family in that .cat part file only. So let us start with that. First I will create this hexagon bolt. For that, I will shift on to the software and I will start mechanical design and part design. So in that, I will give the name Hexagon bolt and I'll say OK. So this is what part design environment we have, and in that part design environment I'll be creating that part. So positioned sketch I would prefer for the sketches, and initially I will take any dimension I want to, because later on, yes, we have to change those dimensions, or I'll say we have to update those dimensions with respect to the parameters that we will be defining. So initially I will take any dimension I want. So next sketch, I'm taking this particular part just because it is a bit simple part as compared to others, and having less number of features, so it will be easy to understand. And I will make it fully constrained and exit from the sketcher environment. Apply pad on that as well, say 15 mm like this. So we have created the parts. Remember one thing, in the pad 2, the sketch 2, I have taken this value, the face to face value for the hexagon. So we will follow the same value over there. There were two values given to us. One is from edge to edge, another one is from face to face. So whichever value we are taking here, the same value we are going to use there. So this is what I have created. Now, as we had decided, there were two parameters in that which are varying. There is some variation in those two parameters. One was diameter and another one was length, which are actually varying in those instances. So what I will do, that I will define those two parameters here. So for defining the parameter, we have to use knowledge toolbar. In that knowledge toolbar, we have one feature named as formula. I will click on that. So there will be one formula dialog box available. In that formula dialog box, I have to define new parameters. You can see over here there are default parameters available. I have created the hexagon bolt. So these are the parameters of hexagon bolt which are generated from the constraints and parameters I have given to the sketches and features. So these are the generated parameters, and over here right now I have to define new parameters. So I will go for new parameter of length type with a single value. I'll click on this. So there is one parameter added over here. Now I will just give the names as per my own feasibility. So say I will give name as dia to this, and I'll maintain say 25 value for this. So one parameter I have defined, say apply, so that will be applied. Next parameter, again new parameter of length type, single value. I'll click on this. Another parameter is available. For this I will give length, say uh, length as the name, and I'll give the value 70. Initially you can define any value, it doesn't matter, and I will say OK to this. So I have defined two parameters for the further work, and these two parameters are available in this file only, but actually directly those parameters are not visible to us. So if you will turn on the settings, then you will be able to see those parameter in your feature tree, specification tree, or history tree. So I will turn on the settings. For that I will have to go for tools. In that tools I will go for options, then infrastructure, part infrastructure, display. In that I have two options available, parameters and relations. I will turn on these two options and I will press OK. So the parameters will be visible to me. Whatever the parameters I have defined, it is visible, and from here only You can double click on that particular parameter, and if you want you can change the value and press OK. So the dependent things will be automatically updated. But again, as of now, there is no such a relation between these two parameters and the part I had created. So we'll move towards the step number 2 that we have to perform is we have to give the relation between these two parameters and the parameters of our part, the hexagon bolt. For that, I will again go for knowledge toolbar, formula tool. So this is our formula tool. Now I will select the parameter from this on which I have to apply these parameters. So from the previous case, from the hexagon bolt drawing, we had seen from this one we had seen that this particular value is the diameter and this particular value is the length. So what I will do, I will apply diameter on this, I will apply length on this. So I will go to the software and I'll just click on the object like this. So the software will show me the parameters over here. So this D20, that is diameter 20. If you will select the parameter here, the same parameter will be selected here in the dialog box. So software is actually considering it as radius. Remember that software is considering as radius, but we have defined that as diameter. So in that case you will need to give the radius value. Okay, so what I want to assign this parameter the diameter. So what I will do, I will select this and go for add formula. On this I want to add the formula, adding the formula. So this is what your parameter in the software, which is equal to the diameter value. So here you cannot type. If you will go for typing, then software will create a problem in that. What I can do is I can go to parameters, renamed parameters. In that, whatever parameter I have defined will be available. I'll just double click on this, so that will be available. But again, software is asking for the radius and we have given diameter. What I will do, I will make it dia divided by 2. As soon as I'll give dia divided by 2, the value of dia was 25. So radius will be 12.5 and accordingly it will create. I'll say OK. And now you can see on this formula is added and value is automatically calculated. Similarly, I will apply on this length. I'll click on this. So that parameter is available. Value is 50 right now. I'll go for adding the formula. Add formula. So this particular thing is equal to, I'll say, length. Select it with a double click. Now the value has changed. Say OK. Yes. So the formula is added. Similarly, I will have to apply the formula on this as well. I had given the S value. I have not used the E value. If you want to use that, you can, no issue. I have used the S value and this K value. So S value is 1.8 into D plus this your K value will be 0.7 D. So I'll go for that as well. I'll click on this, select the value. This will be add formula. Here 1.8 multiplied by, you can use the keyboard for numeric value and symbols, but the parameter you will have to select from here only with a double click. So this will be 1.8 into dia. I will say OK. It has calculated. You can see your object is showing in the red color because it needs the update. Okay, I'll apply on this as well. Say 15, I'll select. This is the parameter. Add formula to this. This was 0.7 into dia and say OK. You are done with defining all four parameters this particular part has. I will say apply. As soon as I'll say apply, the shape of or the size of the particular part will update, and I'll say OK. Now if you want to check, then you can open any sketch or feature and you can check the formula is applied. So you can see over here this 25 has formula is applied. You double click, the software is not allowing you to change the value because it is controlled by a formula. I can check the feature as well. If I want to, I'll double click on the feature. You can see 70. I'm not being able to change it because the formula is driving this. Now if you want to make any changes in this, so you can change the dia or length value from here. Let's say I'll change the dia value. Double click on this, just change the value, update it. Double click on this, change the value, update it, and see, as the parameters are added in the feature tree, all the relations are also added in the feature tree. So anytime if you want to modify or update any relation, you can double click on it and you can update it from here as well. Next, we are actually done with the defining four parameters, sorry, two parameters and four relations in those parameters, and we are able to get the dependency of our part on these two parameters, dia and length. Now what we have to do, we have to define these instances. As we discussed, we have to define these instances a b c d e. These instances we have to define. So, and these are the variable we have. So for that, what we will do, we will use another feature we have in the knowledge toolbar. Name is design table. The design table is sometimes referred as a family table as well, because in this table only you will be defining the parameters of that particular family. Before going for this, just save the file, save. I have already created a specific folder, so in that only I will be saving the file. So this hexagon bolt, and I will save it. In the same folder, I will have to save the design table also. I'll go for design table. There will be one creation of design table window available. Just give the name of design table. Say I will give the name as bolt table. You can give any name you want to, any comment you want to give for that, so you can give that as well. Then there are two options: create a design table from pre-existing file, and another one is create a design table with current parameters value. So as of now I do not have any pre-existing file, so I'll use the option number 2, create a design table with current parameter values. The parameters we'll use are your diameter and length. So I'll select this and say OK. As soon as I'll say OK, one window will appear which will ask me which parameters. So from the list, I'll select the parameters which I have to define for design table. So dia I had selected, length I'll select, and I will say OK. Now I have defined the design table, how I want to create. I have also defined the parameters I want in the table. Then the software will ask me to save the Excel file. Software automatically generates the design table Excel file, and definitely I will save the same file in the same folder. So bolt table.excel file, I will save it. The saving process actually takes some time, because from CATIA you will be migrated to Microsoft Excel. Then from Microsoft Excel, the software will create the file using the parameters you have defined. So this process takes some time, and then it will show you the result. The result will be in the form of design table. So you can see the software has saved the file, and now I am able to see the design table window. In that, current two parameters are available, dia and length, and there is one line shown over here. This is one of the instance that I want. Okay, now to define more instances, I will go for edit table. As soon as I'll click on edit table, the software will execute opening the design table, which is your Microsoft Excel. So the software will open Microsoft Excel now. It has been opened. Yes. So you can see in the Microsoft Excel, I am able to see two columns having dia and length. Now we want to give the instances here. We will need to define the instances name as well. So I will add one more column before that, and in that column I will define part number. Make sure you write down the part number in the same manner. This P and N will be capital and there will be no space between that, because software has part number defined in such manner only, so that it can detect the instance name you want to give. So define it in that manner. Now we have three columns, and we will have to define that the other parameters. So the other parameters are, sorry, other parameters are value of, like, part name or part number is A, values are diameter 10, length 30. I will define that. A, diameter 10, length 30, like this. B, for B, then for C, D and E, I will define it like in that manner only. So 15, 35, 20, 40, I'll say 15, 25, 20, 40, then 25, 50 and 30, 60. Okay, again I can take any values as I want, it doesn't matter, because this is just an example. So like this I have defined 5 instances. You want, you can define 50 instances, it doesn't matter. What I will do, I will save the Excel file and I will close the Excel. Once you will close the Excel and go back to the software will do some more processing, and it will synchronize your table with the cat part file, and you will receive this message: the this design table has been synchronized with this file. Say close, and you can see the synchronization has happened. The diameter and the length has been updated. Now you can take whichever instance you want. Just double click on that instance, that will be available. If you want, you can check it over here. Diameter was 25, now you can see the 25. If you want some other instance, go for relation. In that relation you will find the design table. Double click on this to activate, and then again double click to open. Let's say I'll select another instance, say 1525. Now activate the part with a double click. Check the values. 15, height is 25. I got the result. This is what we have, what I had done. I had created the parameters, then I had created the relations. Using both of them, I had created the design table. I will save this file again, and now what I will do, I will try to insert that into the assembly, because I have created the family table, or I will say the part family. So I'll go for a start, mechanical design and assembly design. I will insert first part, existing component, into the assembly, and I will select from the same folder, I will select the part file, say hexagon bolt, the part will be inserted. Then I will again insert the same part, because as I have created 5 instances in that, so I will create 2 parts, then I will change one. So I will fix the first component like this, then go for existing component in the product, hexagon bolt again. I'll just manipulate one like this so that I can see the differences. These are arranged in that manner. Now you can go to any of the part. You want to go for one, you can go for one. You want to go for two, you can go for two. No issue. Whichever you want, just go for the relations. The tree is available. In that tree, double click on the design table to activate that. After that, double click again to view and select some other instance. So I'll take 3060. Now you can see, as I had changed the instance, both the parts are updated. What we had to do, the result that we want was, I don't want to update both the parts. What I wanted was, I will take one instance in one part, I'll take another instance in another part. For that, we will need to take the help of catalog. So I will close this file now. I'll say no to this. I don't want to save. I will go for creating the catalog. For creating catalog, you will need two things. First, your .cat part file, and second, the design table linked with that cat part file. So I'll go for creating the catalog, start, infrastructure and catalog editor. Software will open the catalog editor environment. In that chapter toolbar, last option we have to add the part family. What we will do, we have created two files, the cat part file, the design table file, the Excel one. This catalog will actually mix those. Okay, so I will go for creating the adding the part family. Click on this, give the name of family. So family name will be definitely hexagon bolt, and in that I will select the document. The document will be your hexagon bolt dot cat part file. Select it. Selected, say OK. Once you will say OK, so over here your hexagon bolt file has been added. Then supporting document to this, I will select the Excel file I have. Sorry, in the same folder I had saved the Excel, so that bolt table Excel file I will select as the supporting one. This your cat part file, this will be your Excel file, and finally you can save the catalog. It will automatically mix. You can give the name hexabolt. I will give hexabolt dot catalog file will be saved. That's it. You are done with creating the catalog. Now you can use the same catalog in the assembly design environment. So start mechanical design, assembly design, catalog browser. You can go for, yes, over here default you can find the ISO standard parts, US standard parts. You can see ISO standard is there, US standard is there, JIS, EN standards. Whichever you want to use, you can select. And you can see these are the default parts, because this is the library we have, default library. So as per the ISO standard, if you want say nuts, double click on that. These are the variety of nuts available. Select any of them. In that again you will find more variety, or I will say the more parameters. So whichever you want, let's say you want M6 steel grade A washer faced hexagon head, double click on that. That particular thing will be available in your assembly design environment with its complete feature tree and parameters. This was about your standard part, but I have also created one catalog. So I'll delete this for now. I don't want to use this right now. I'll go for catalog editor and I will browse my own catalog. So browse another catalog and I will go to the folder which I had created. In that I had saved hexabolt.catalog file. Select it, say open. You can see I had given the name to the family Hexagon bolt. Double click on that family. These are the 5 instances that I had to define. These are the 5 instances available with the values and their number, or I will say the name, whichever you want. Double click on that, that will be inserted. I have selected the C is inserted. Say OK. You can apply constraint fix on that. Again you won't say E as well. Double click on E. That E instance will also be available. OK. I'll close this. You can see both the instances are available at 0 comma 0 comma 0. You can manipulate and you can see both are available separately with their dimensions, with their parameters, which I had defined in the design table. This is what our solution is. So what we are able to do, we are able to maintain multiple parts having same shape but different size in a single file only. This is what your part family is. This is how you can create and you can maintain the part family in CATIA V5 environment, assembly design, or I'll say part design environment. Thank you.